Alright, welcome back. I know I say that a lot. So let's do this example. So we're going to solve this polynomial inequality. And so we're going to go through the steps. So the first thing we're going to do is we're going to move everything over to one side of the inequality, just like we did with equations. So I'm just going to move everything over to the left. Okay? So if I move everything over to the left, I'm going to subtract 10 and I'm going to add 2x. And so that means I'm going to do the same thing over here. So I'm going to subtract 10 and I'm going to add 2x. So what does that give me? Well, these go away, and that gives me what? 3x times x minus 1 minus 10 plus 2x is greater than 0. Okay, so now I'm going to simplify the left. Now, could you have expanded this out over on this side first and then moved everything over? Sure, it doesn't matter. Okay, so let's now expand and add like terms and simplify. Okay, so I'm going to expand this out. This is going to give me 3x squared minus 3x minus 10 plus 2x is less than 0. Now I'm going to simplify. So I've got 2x minus 3x here. So that's going to give me a minus x. So this is going to be 3x squared minus x minus 10 is greater than 0. So now what I'm going to do is I'm going to set it equal to 0 and find all the real solutions. So 3x squared minus x minus 10 is equal to 0. So now I'm going to use all the tools that we've learned, right? Go through the tools. So here I've got the AC method, right? Or method of decomposition. There's no greatest common factor here. There's nothing else I can do here. So immediately the AC method is the best method that we can use. I wouldn't use the quadratic formula because this is probably factorable. You would only use the quadratic formula as if it's not factorable using other tools. So if we multiply these two together, we get negative 30. And so now we need two factors of negative 30 that give us negative 1. Now the fact that this is negative, right, means that they have to have opposite signs. The factors have to have opposite signs. The larger factor is negative because the middle term is negative. But also keep in mind, because this is really small, this is 1, that tells you the factors are really close together. Okay? So they're going to be factors that are going to be towards the middle. That's what I always say. But so where are the factors? There's lots of factors. But where are the factors that are towards the middle, right? You've got 1 and 30, right? But those are really far apart, okay? And those won't work anyway. So we want two factors of negative 30 that are really close together. So what are two factors of 30 that if we subtracted them, that would give us 1? That's what we're looking for. So in this case here, let's see, we got 3 times 10. 6 times 5. Perfect. 6 times 5. Okay, we got 6 and 5. Now, the middle term is negative, so that means the 6, because it's larger, is negative. So it's going to be negative 6 and 5. So now we're going to decompose the middle term with those two factors, negative 6 and 5. So we got 3x squared minus 6x plus 5x minus 10 is equal to 0. Now we're going to group factor by grouping. So this is going to give me what? So I'm going to group these two and I'm going to group these two. So this is going to be 3x times x minus 2 plus 5 times x minus 2 is equal to 0. And now I've got the common factor x minus 2, so I'm going to factor that out. And I'm left with that. So now, there are no values of x that are going to make this undefined. In fact, for all polynomials, okay, for all polynomial functions, there are going to be no restricted values, no values of x that are going to make it undefined. In fact, polynomials are defined for all real numbers, okay? When we get to rational expressions, that's going to be different. But when we're dealing with polynomial inequalities, there are going to be no restricted values. So the only thing we're going to be looking for are the zeros. We're going to be looking for where does it touch or cross the x-axis? Where are the x-intercepts? Okay? So in this case here, our x-intercepts are going to be at what? At x equals 2, right? Because if I plug 2 in here, this becomes 0. And the other one is going to be, well, what's going to make this equal to 0? That's going to be negative 5/3. Okay? And again, you could just solve these equal to 0. You could set this equal to 0. And I highly recommend you do that until you start thinking about this. Okay? Set them both equal to 0. Use the zero product principle. Don't forget. So now, x equals 2 and x equals negative 5/3. Those are the two zeros. And those are going to be your boundary points that you're going to test. So now, what are we going to do? Now we're going to use those. Those are the boundary points of our intervals. So what's the intervals, right? So let's do our intervals. So what are our intervals? We've got interval what? We've got from negative infinity to negative 5/3. We've got from negative 5/3 to 2. And then we got negative 5/3 to positive infinity. So now we're going to take a point in each of these intervals. We're going to use a test point to find out the sign of f of x. So we'll put sign okay, now I'm going to write out the stuff again. So this was, what was it? Oh, 3x plus 5. Wah! So yeah, so we got 3x plus 5, right? So now what we're going to do is choose a value in this interval, and we're going to see whether it's positive or negative here. So let's choose, well, this is negative 5/3, so that's bigger than negative 2, so let's do negative 2. Well, oh, hold on a second. Yeah, let's do negative 2. Well, if we put a negative 2 here, this is going to be negative. If we put a negative 2 here, this is going to be negative. A negative times a negative is positive, so the sign here is going to be positive. Now, let's choose something in this interval. Let's choose 1 or 0. 0 is an easy one. 0 is in here. Let's just do 0. So we're going to get negative here. So if this is 0, we're going to get negative. If this is 0, we're going to get positive. So negative times a positive is negative. So the function is negative on that interval. Okay? Now let's choose something on this interval. Oh, hold on. I made a mistake. This should be 2. So on this interval, let's just choose 3. We'll put 3 here, it's positive. Put 3 here, it's positive. Positive times a positive is positive. Now, think about this for a minute. If we're solving for the zeros, and we know the zeros are where it's going to touch or cross the x-axis, right? Then we know that anywhere on this interval, it has to be either above or below the x-axis for the whole interval. Because if it wasn't, we'd have some more zeros. So all we need is one test point on the interval. And as long as we can verify the sign for that one point, it has to be true for all of the points on that interval. Okay, so that's why we only use one point. Now the cool thing is you can use this to say, hey, what's going on at the zeros? Here it goes from positive to negative. So you know it has to be crossing at -5/3. And then again, it goes from negative to positive at 2, which means again, it's crossing the x-axis. Okay? Which also makes sense because the multiplicity on both of our factors is 1. Right? So both of our zeros have a multiplicity of 1. So again, just making the connection from what we learned previously. All right, now, in this case here, because we're dealing with a polynomial, the zeros are included in our solution set. They're not restricted values, okay? Okay? So that means for our solution set, let's see here. So for our solution set, we're looking for, again, let's go back to the original problem, right? It was, so I'm just going to, in factored form, I'm not going to go back to the original one. So what we have to solve is x minus 2 times 3x plus 5 is what? Greater than 0, right? That's what we had. So now, well, the solution is what intervals satisfy the inequality greater than. Okay? Now, so I misspoke a little bit because I was thinking about equals, but forgot we're dealing with the inequality. So, we would not include the endpoints in our solution set because in this case here, they are equal to 0. We want everything that's greater than 0, so we would not include them. Furthermore, because this is negative, this interval is not included. Okay? So our solution set would be what? It would be the union of this and this. Okay? So in interval notation, we would write it like this. The solution set would be negative infinity to negative 5/3 union 2 to positive infinity. Okay, that's interval notation. If we wanted set builder notation would be like this. We'd start with our curly braces, which is for set builder. And we would say the set of all x such that x, oops, there's a couple different ways we could do this. Such that x is less than negative infinity and, oh no, not less than, greater than. And less than negative 5/3, or x is less than positive infinity and greater than 2. We can write it like that. Okay, so that would be using set builder notation. All right, we'll do another one.